Okay. So go ahead and copy down the definition at the top, and I'm going to give you that clip art to glue down in your notebooks. Okay, so let's look at these and determine which ones are functions, and we'll just say yes or no. This was H, I, J, K. All right, so for it to be a function, x and y in a relation where each element of x is associated with only one unique element of y. Another way to say that is you can have no repeats in your x values. No repeats in domain. Okay, so let's look at this first one. When it's an ordered pair, I think it's a little easier to check. So I'm just looking at x. I'm looking at these 4 numbers that I have highlighted in yellow. Are any of those numbers the same? All right, so this is a function. So A would be a function. And that's it. It's that simple. In your homework, you have sets of relations. You have to determine which relations are functions. Go ahead and look at B and C and figure out if you think they're functions. What would you say for B? Yes or no? So let me go ahead and highlight the x values again. So if I'm looking, I got a 1, a 2, a 3, and a 6. Those are all different. So I would agree that that is a function. What about C? Is that a function? No. Notice that we have a repeat, and what value in our domain repeated itself? See, these two are the same, so C is not a function. When you're looking at an equation, you want to look for exponents on your y variable. So when we're looking at these next three, D, E, and F are all functions. But the last one in this column, G, is not a function because of that y squared. So you can have an x squared, but when you graph y squared, it's going to fail the horizontal line test. So this is a function. But again, this last one, G, is not. Okay, so now let's look at maps. So when you're looking at a map, you're checking to see the arrows that come off the first oval, which is X, and the second oval is Y. So if you have 2 arrows coming off of one element in this first oval, that's what that will cause it to fail the vertical line test. So when I'm looking at this one, I'm noticing that these points, even though I don't know what they are because they're just dots, it doesn't matter what they are, okay? There's no repeats because every single arrow is going from one to another. Even though sometimes 2 different arrows connect to the same value in the Y column, that's okay. But if you look at I, notice this here, those 2 arrows coming off that element. 2 coming off one element means that that order pair is sharing the X value with 2 different Y values. So this would be a no. That's not a function. This one is yes, this is a function. And then for J, when you're looking at a graph, you want to check for the vertical line test. Remember that from Algebra 1? So if you can draw a vertical line, as long as it crosses it just once, it's a function. So when I'm looking at this one, if I draw that vertical line right here, it doesn't matter where I draw it, it's only going to cross through the graph once. So this would be a yes. But the circle, if you draw a vertical line, that crosses through that circle twice, so that would be a no. So, this is what I gave you. This is what I gave you to glue down. So instead of you having to write this whole slide down, I just gave it to you to glue it down. So go ahead and glue this down, and then we'll talk about it. So another big part of chapter 2 is finding the domain from an equation. So I like to think of them as red lights. As long as you don't have a red light, your domain is all real numbers. Okay, so that's why it says start with all real numbers. So we're going to start here, okay? But if your equation has one of these red lights, then we need to pause. The first red light is a denominator. The denominator, if you have an x in your denominator. So for example, if you see a denominator, but not just a denominator, it has to be an x in your denominator. So if you have y equals 4 equals x over 4, that equation would have a domain of all real numbers. This would have a domain of all real numbers. So when I say denominator, more specifically, I should say a variable in your denominator. That's what causes the domain to not become all real numbers. If you just have a number in the denominator, that's still okay. That's not a true red light. But if you have x in your denominator, then you do not have a denominator. You can't have a domain of all real numbers. So let's look at this one that I put on your first example. You see this example where it says x minus 3 over x minus 2 over x plus 3. You have to exclude any number that make the denominator 0. Okay, so let's focus on our denominator. So our denominator is x plus 3. If you take x plus 3 and you set that equal to 0, you get that x cannot equal negative 3. So that's the only number that x cannot equal. So how would you write that in interval notation? Well, you would say your domain goes from negative infinity to negative 3, union negative 3 to positive infinity. That's how you exclude the domain. And we put a parenthesis on the negative 3 to show that that number is not okay. No, because if you put a bracket, that means we can use it. And we cannot use negative 3. Negative 3 would cause a 0 in your denominator. If you have calculators on your desk, if you try to divide a number by 0, any number, and you try to divide it by 0, you get an error. Most calculators say domain error. Some say divide by 0 error. You cannot divide by 0. So that's your first red light. The second red light is a square root. And to be more specific, I want you to include not just any radical, it has to have an even index. So not just, if you have a cube root, that's okay. But if you have a square root or a fourth root or a sixth root, then that is a red light. And we have to, because you cannot take the square root of a number that's negative. So how do you do that? Well, what you're going to do, and we're going to do some examples together, obviously, but take what's underneath your square root, only what's under your square root. So in this example, that would be x minus 5. So take that x minus 5 and set that greater than or equal to 0. Notice that for a square root, it can equal 0, because you can take the square root of 0. You just can't divide by 0. So this will have a bracket, because 0 is allowed, but you can't go less than 0. If you try to take the square root of -1, it's going to say imaginary. You cannot take the square root of a negative. So when you solve this equation, we add the 5. We get x has to be greater than or equal to 5. How would I write that in interval notation? Because everything we do is in interval notation. Would that be -infinity to 5 or 5 to positive infinity? If it's greater, 5 to positive infinity. And now you can use a bracket. So your domain would be 5 to infinity. And that would be that. So we're going to do some examples together. We're going to just look at some equations. We'll go one by one, and we will find the domain. Okay, anybody need more time? All right. So let's go ahead and copy down these first 3, and then we'll go through them together. We'll find the domain. Remember, we're looking for a red light. If you don't see a red light, the domain is all real numbers. So go ahead and copy those down, and then we'll find the domain together. Okay, so let's look at this first one. Do you see a fraction with an x in the denominator? That's your first red light. So do you see a fraction? No, there's no fraction. It says 3x minus 4. Do you see a square root? So your domain is all real numbers. If you don't see a red light, your domain is all real numbers. That's it. Nothing needs to be done. Let's look at question B. Do you see a fraction? Do you see a square root? A square root, not a square. Do you see a radical or a square root? No. So what's your domain? All real numbers. Question C, do you see a fraction? Do you see a square root? Yes. So when you see a square root, you take what's underneath the square root. Now, if there was something in front of this square root or behind the square root, that does not affect my domain. Only what is underneath the radical. You're going to take that 3x plus 2. I want you to set that this has to be greater than or equal to 0. So that 3x plus 2 has to be greater than or equal to 0. Go ahead and solve that for x. So to solve that, what would be your first step to solve for x? Subtract the 2, yep. Do I have to flip the sign when I subtract and it's a negative on the other side? When do you flip the sign for inequality? Divide or multiply by a negative. So now I have to divide by a positive 3. So what I get is that my domain x has to be greater than or equal to negative 2/3. So in interval notation, it would be bracket negative 2/3 to infinity. And that would be my domain. Yes. You flip the sign when you divide by or multiply by a negative. And I had to divide by a positive 3, so you do not flip the sign. All right, so we'll write down the next 3. All right, go ahead and copy down those 3. We're going to write our domain. Okay, so all 3 of these have red lights. We have 3 fractions, but more specifically, there's an x in the denominator. So again, if it were something like, I'm just making this up, but if it was f of x equals x plus 2 over negative 1, if I take this x out of the equation, then my domain is still all real numbers. Okay, this is still all real numbers. But when I put an x in the denominator, that's a red light. That's where we have to stop, okay? And the reason why we have to stop is because we cannot divide by 0. So we have to take away anything that will cause this to be 0. So if you take x minus 1 and you set that equal to 0, you get x cannot equal 1. That's the only number from negative infinity to infinity that x cannot equal. So if you were graphing this on the number line, so did I say negative 1? I don't know. Sorry. Okay, so there will be an open circle here. So everything to the left of 1 and to the right of 1 would be okay, but just not 1. So to say that in interval notation, you would say your domain would be negative infinity to 1. Do I put a bracket on the 1 or a parentheses on the 1? Parentheses, because a bracket means that it's okay, but it's not okay. So we have a parentheses, and then we have union to show that there's a break, 1 to infinity. So it's kind of like our domain is split into 2 pieces. Any questions about that? Yes?
The reason you put infinity is because it can be any number but 1.
Any number but 1. So it could be any number, literally any number other than 1. For E, there are 2 numbers that I have to take out because this is going to factor down. Again, I'm focusing on this. This factors down to x plus 3 and x minus 3, which means x could not equal positive or negative 3. So that's 2 numbers that we have to take out. So that means that my domain is going to split into 3 pieces. So I'm going to graph it, like make a sketch of it so you can see it visually, and then we'll write it in interval notation. So negative 3 and 3 are the 2 numbers that we have to throw out. So I have an open circle and an open circle. So I use 3 different colors. So like the red part would be a domain, and then the green part, and then the blue part. So how would I write this red part? From what to what? What number is over here? Negative infinity. So my first piece of my domain would be negative infinity to negative 3. Negative 3 is less than 3, so that's why I put negative 3. I put the numbers in order. So from negative, so I always think of this as, okay, I'm riding along on the train track, so negative infinity, and then I have to come to a stop at negative 3. So from negative infinity to negative 3, then I have to get off the train, then I have to get back on the train. It's like I have to step over this. Okay, so I'm stepping over it. And then when I get back on, I can ride from negative 3 to positive 3, and then I have to get off again. So it's like 2 big potholes that we have to get off. Okay, and then I get back on again at positive 3, and I can go to infinity. So notice that I had to break it. It just depends on how many numbers I'm throwing out. Yes, ma'am.
So do you prefer us using the line?
No, I just put that there so you could see it visually. If you don't need to, I mean, I just didn't know if you needed to see it, you know, so since we have a quiz next Friday, you know.
Over all this?
Over what we're starting today. Yeah, 2-1 through 2-3. Okay, so now let's look at G, or the last one. I want you to try to do that one by yourself, because that one is like D. So see if you can set that up and write your domain. So 8 is okay, because if I put an 8 right here, in my denominator, what is 8 plus 8? 16. So 8 is okay. We need to figure out what number would cause this to be a 0, and that's not positive 8. Negative 8. Because negative 8 plus 8 would be 0, and you cannot divide by 0. So x cannot equal negative 8. That's the only number that's not okay. So if I were to sketch that on a number line, this is what that would look like. You would have the left side of negative 8, and you would have the right side of negative 8. So you would say negative infinity to negative 8, union negative 8 to infinity. And that would be your domain. Couple more, and then we'll end. Just 3 more for today. Or maybe not. Well, we can at least write them down. Go ahead and copy down these 3. So for G, we do have a red light. Only this part, this is the only part I'm concerned about. That's the only part that I care about. That part of your equation is why we have a red light. So you take that and only that piece. Set that greater than or equal to 0. This negative 5 does not affect my domain. And this 2 in front does not affect my domain. It's what's underneath the square root. Only take that piece, set that greater than or equal to 0, and let's solve it. So the first step would be to subtract the 1. And now I have to divide by a negative, and when I divide by a negative, what do? Flip the sign. So I'm dividing by a negative 4. So it's going to become x is less than or equal to positive 1/4. So how would I write that in interval notation? Less than. So would that be negative infinity to 1/4 or 1/4 to positive infinity? Negative infinity to 1/4. And remember that we can use 1/4 because you can take the square root of 0. So the 1/4 gets a bracket and the negative infinity will get a parentheses. All right, we'll end there and we'll pick up on H and I tomorrow.